Hello, Nagarjuna Mahendra here.
Yeah, Mahendra. Yes, yes, please.
Yeah, can you please make me an organizer?
Mahendra, actually, when I make you organizer, you are not able to hear my voice for some reason.
Yes, yes.
So
Earlier it was fine.
yeah,
The meeting was.
because usually this happens, Mahendra. Because I usually take classes, right? This happens for one or two participants. So what I suggest is this time when I make you organizer, if you're not able to record, I'm actually recording this session, and I will pass on the session to you. Yeah.
Yeah,
But I'll make you organizer. But I'll make you organizer. Yeah.
Yeah. Okay. Okay.
If you're not able to hear me, hello Mahendra, are you there? Hello. Okay. Anyway, I think he's not able to. Even I can't hear your voice. Please leave. Please leave meeting and join again. Just give me 2 minutes. Yeah. Participants having some problem. Okay, we'll start the session. Banu, I'm not making you organizer. Please listen. I'll continue the class, and after the session, I will pass on the session to you. So today we are going to see calculation views of type star joins. So usually whenever you're doing master data modeling,
Sorry, Nagaji.
Yes, please.
Can you please make me as an organizer?
Yeah, I'll make you, but your name, please. You've joined as
Banu. Yeah, Banu.
Okay, Banu. Actually, when I make you organizer, what's happening is you're not able to hear my voice. But I'll make you organizer. If you're not able to hear my voice, please leave meeting and join again. Or if you don't want to make you organizer, then I will record session and pass on to you.
Okay, thank you.
So you want me to make or no?
Just make me as an organizer, and if not, I will ask you to send me the recording.
But if you're not able to hear, please log out and log in again, yeah?
Yeah, sure.
Okay. So today, everyone please mute yourself, please. Please mute yourself. So today we are going to start with calculation views of type star join. So if you see, for master data modeling, whenever you want to model master data, there are basically two ways. Basically two ways that you can model. One is using an attribute view, Banu, please mute yourself, please. Please mute yourself, Banu. One is using attribute views, and the other one is using calculation views of type dimension. So both are used for master data modeling. So when you double click on the attribute view, if you see data category is dimension. If data category is dimension, then it is for master data, because dimensions hold master data. If you see the definition of attribute view, attribute views are reusable dimensions, subject areas where it is used to join master data tables. So basically, attribute views provide descriptive data to the analytic views. And using analytical views, you can do a multi-dimensional analysis based on the star schema modeling. Then why do we have two objects for doing master data modeling? Because when you create a star join, using calculation view of type dimension, we cannot use attribute views to provide master data to this dimension. We cannot use it. There is a limitation when you want to use a calculation view of type star join. We cannot use attribute views, nor we can use analytic views. It's not possible. This limitation, when you create a calculation view of type star join, you cannot use attribute views or you cannot use analytic views inside calculation views of type star join. So, to provide master data to the calculation views of type star join, we have to input calculation views of type dimension to provide master data to the transaction data. To create a star schema, so this dimension would be this, but not this. So if you right click on a calculation view and click new, you would see three data categories. Data category of type cube with star join and a dimension. Now let's start to create a calculation view of type dimension, where this dimension provides descriptive data to calculation view of type star join. Right click on the calculation view, click new, give in CV underscore start join. I'm sorry, CV underscore dimension underscore customer. So we are creating a calculation view of type dimension. There's some disturbance coming. Could you please mute yourself kindly? Banu, could you please mute yourself? A lot of disturbance is coming. Data category would be dimension and click finish. Now once we finish, so in the projection, we can directly provide the master data tables, or in order to create a scenario for customer, click join. So now we are going to create the same scenario as attribute view customer at the calculation view. So if you click semantics, please see data category is a dimension. So click join and click here, add objects, KNA1, HANA user, from KNA1 from HANA user, and T005T, double click. So in the join, you see here KNA1 and T005T. So join land 1 to land 1, join type is a text join, in language column SPRAS. So these are simple joins. We cannot take more than 2 tables in this join. They're simple joins. The output I require is KUNNR, land 1, name 1, regio, and I would require the description for landx. So this is my output over here, which is KUNNR, name 1, land 1, landx, and I would require the text for region. So click join and give input join 1 to join 2. So at the join 2, we would provide T005U from HANA user. Now let us join join1 and T005U to get the description, which is BZEI. So join land1 to land1 and regio to bland. Select the join type, text join, and language column sparse. KUNNR, name1, landex, and BZEI. So here, once you create joins, and join 2 will be input for projection. So finally, at the join 2, we get the output, that is KUNNR name1, that is customer name, customer country, and customer region. So we got the desired output. So we are doing similar to attribute view. So attribute views also executes on join engine. Sorry, attribute views executes on join engine, and calculation views executes on calculation engine. But output of attribute view and this view is both are same. There is no much difference here. The way output is shown, but only difference here is because attribute views cannot be used in start join, we have to do something like this. There's a limitation to use attribute views. That's why we create calculation views of type dimension. But both give the same output. I'll show you now. So finally click semantics. Make KUNNR as key attribute and give the label mapping. KUNNR name1, land1, landex, regio, BZEI. Name1, landex, and BZEI. And finally click save and validate and save and activate. So here we would see I created CV dimension underscore customer. So I just activated, activation completed successfully. Let us see the output now. I click on the customer data preview So let us compare the output between both of them. Click raw data. So it's shown in Chinese because I think someone changed to Chinese in the language column. So instead of this, let me put in English so that we can see descriptions in English. Click apply and click OK. Let us come back to the development package. Right click on the dimension and data preview and click raw data. Still shown Chinese. Haven't I changed over here? Let me apply and click OK. Yeah, it's shown English now. Yeah. So let us basically check for the values between attribute view of customer and calculation view of type dimension customer. So let us take one customer here. Let's take any customer. For example, let me take Homemade Foods, United States, Texas. So this is the customer over here. Let me copy the customer and let me check this customer in the attribute view. Right click, data preview. So invalidated view. So whenever you have this error, invalidated view, what you can do is double click on the customer attribute view, click save validate and save and activate. Click yes. So it throws an error. So let us try to analyze the error. So it says there's an alias name. So let me remove this alias name.
Hello.
Yeah, hello? Yes, please.
Yeah, just why, but we are not able to hear you. That's why I called.
Yeah, I'm not talking actually now. I'm just changing this.
Okay.
Yeah? I'm not talking now. Please go. So let us check for the customer. So the value in the attribute view as well as the calculation view. And this is the old one. The value in the calculation view. So this is the one for calculation view. CV dimension. And this is the one for attribute view. Please see, both the output is same. IT 24005, IT 24005, both are same. The output is same, but how we done modeling is different, and what engines it executes is different over here. The attribute views executes on join engine, and a calculation view of type dimension executes on C engine. If you have any doubts until here, excuse me, I'm sorry for that. If you have any doubts here until here, please let me know. Until the calculation view of type dimension, before we proceed to the next one. I'll unmute everyone. If you have any doubts, you can go ahead. Okay, so we'll proceed to the next one. So next I'm going to create one more attribute view for company code, and the same with the calculation view. I'll show you both the ones, and let us see the output for both of them. So I click on the attribute view, click new. Yes, I'm showing you the difference in modeling in both of them by creating both. AT underscore company code, attribute view of type standard, click finish. So this is where we are going to create complex joins, because attribute views are based on entity relationship models and they execute on join engine, that is JE. So at the data foundation, I click add objects, and then here you can specify the required tables. So I would like to take BUKRS, I'm sorry, T001. I would like to take T001, TVKO, TVKOT, and TCURR. So what are we trying to achieve over here? The output I require is, I would like to show what is the company code, and this company code belongs to what sales organization, and company code deals with what currency. That is what we would like to display over here. Company code, name of the company code, sales org, name of the sales organization, currency of the company code. So the company code column is BUKRS. Name of the company code is BU text. Sales org is, and name of the sales org is currency of the company code. Not TCURR, it's not TCURR. The table is TCURT. So the currency code is WAERS, and the text for the company, text for currency is, it is L text. So in here, let us do the joins now. So company code BUKRS, join BUKRS to BUKRS of TVKO, because here we are trying to get the company code 1000, and what is the sales org. So if I right click on the table, data preview, select distinct values, select BUKRS is 1000. What is the text for 1000? That is BU text. So when BUKRS is 1000, if you click on raw data, give 1000. So 1000 is best run Germany. The 1000 company code has what sales organization? In Germany you have different sales orgs. So if you come back, right click on TVKO, data preview, click raw data, copy paste, enter. So if you try to filter on 1000 company code, add filters, company code, try to filter on 1000, click OK. For 1000 company codes, all these are different sales organizations. So one company code can have multiple sales organizations. But how to know text for these sales organizations? Click back. This join would be inner join because we would like to have 1000 to 1000, so it would be the common values between both the columns. Inner join. So now at the BUKRS, we have given here join to the BUKRS. From VKORG, we join to VKORG, and this would be a text join. Double click on the join, taken as text join, and language column would be SPLAS, and click OK. 1 minute guys, just please give me 1 minute. Sorry for that. Sorry. So here, once we take text join, so join WARS with WARS, and L text is the currency. So here we would like to take company code BUKRS. The company code name is BU text. Sales org is VKORG, and name of the sales org is VText. Company code, currency of the company code is WAERS, and the currency is L text. So if this is 1000, run Germany is the company code name. This is the name of the company code. And so based on this join, we are trying to retrieve the sales org. If you see the company code here, you have different sales organizations. So each sales org has a description. So in order to get description, we join on the sales org and get the description, which is vtext. Now in order to get the vtext, right click on TVKOT, data preview, click raw data. So let us filter on SPRAS PRAS, which is English. And here you have different sales organizations. Like for example, if you given 1000, please see, for 1000 you have Germany Frankfurt. Is a description of the sales organization. So here the sales org is 1000, and this would be Germany Frankfurt. And TCURT, data preview, and finally the currency. add filters on English. So all the currencies in the alt text. If the WARS is USD or EUR, euros. So WARS is EUR, means alt text is, you see the alt text, it would be euro. So this is the output of the attribute view. So between this company code I taken as an inner join, and for this I taken as a text join. For this we need to take it as a text join because we are joining the text table. Now let us arrange all the columns. First is BU KRS, BU text, VKORG, VText, WARS, alt text. Finally click on semantics and then make BU KRS as key attribute. And BU KRS to BU text, VKORG to VText, and WARS to alt text. And hide alt text, VText, and BU text. Click validate and save and activate. So once this is done, or let us see AT underscore company underscore code. Right click on this data preview. Click raw data. So finally, if you enter the company code 1000, please see, for company code 1000, these are the different sales organizations. For each sales organization, this is the currency that it is operating on. Now if you take a different company code, let us take the currency as USD. So let us take 3000 as the company code. The company code 3000 is USA, and these are different sales organizations. Philadelphia, Denver. So these are different sales organizations in the US company code, and this is what the currency they are operating in. So by joining all these 4 tables, we are able to get this information. So the same model now I'm going to create in the calculation view of type dimension. Right click on the calculation view, click new, and create CV underscore. Okay, so before I create the new one, if anyone have any doubts until here, please go ahead. Until the company code attribute view. I'll show you the difference now when we create a calculation view. So please see, I've created a complex joins. I've taken 4 tables and I've done everything in one data foundation. So now we're done with the attribute view. The same thing I'm going to create in a calculation view. Anyone have any doubts until here? Okay, so we create calculation view of type dimension now. So click calculation view and give in CV underscore company underscore code data category dimension and click finish. So take join, click on the join and click on the join. Add objects. I'm doing the same one, same modeling I'm doing again. T001, TVKO. Please see, I cannot take more than 2 tables. The plus icon is disabled now. Please see once again. You see the plus icon here? Now when I click add objects, TVKO, I don't see the plus icon anymore. So let us do the same modeling. So BUKRS with BU, I'm going a little fast over here because we just done this. So same relationships here. So BUKRS, BUKRS, and this would be inner join, and the output we require BUKRS, BU text, VKRG, WAERS, take one more join, join 1 to join 2, at the join 2 TV KOT HANA user. Join VKORG to VKORG. Join type is text join. Language columns class. vtext, bukrs, butext, wars, and this would be text join. Click join again. Join 2 to join 3. Add objects. Now TCURR, sorry, TCURT. HANA user. So join WARS to WARS, which is join type would be text join, and language column would be slash. LText as output. So we require VKORG, vtext, BUKRS, BUText, and LText. So let us arrange this. BUKRS, BUText, VKORG, vtext, WARS, LText. And join 3 to projection. And finally, here is the output. Company code name, sales organization, and currency. So if you want to do, click auto arrange. Click semantics, give in the key attribute, and do the label mapping. BUText, vtext, and LText. Hide the descriptive column, perform label mapping, validate, save and activate. Now let us compare both the views. Right click on the calculation view, company code, data preview. The output should be same. Click raw data and giving the company code 1000. Please see, this is the output from the calculation view. And also let us see from the attribute view. I click data preview, raw data 1000. Please see, here you see 7 entries, and here also you see 7 entries. Until here, any questions? Please go ahead. You have any questions until here? So what's the difference over here? So this one, when I execute, it executes on JE engine. When I execute this one, this executes on CE engine. So that's the primary difference. But the output for both of them is Ashraf, Murli, Mahinder, Zubair.
Yes, Nagarj, Mahendra here.
Yeah.
Yeah, no doubts from my side.
Okay. So I'll move on to the calculation view of type start joints then. Now here, we're going to the second one. So until now we focused on the first one, which is calculation views of type dimension. And now we focus on the second one, which is calculation views of type star joints. So let us come back, and now right click on the calculation view, new, CV underscore actual underscore plan underscore copa underscore data. Let me give it this as start join. Data category cube with start join. And click finish. Now, can we use attribute views inside the star join? TC? No. So drag and drop attribute view called, I just created this one. Let me drag and drop here. So does it take here? It doesn't allow. Please see. Then how am I going to provide the descriptive data for the transaction data, for the quantifiable data? It's not possible like this. So the alternative way is the same functionality of this. I built it in calculation view of type dimension. select this, drag and drop into start join. So please see this one allows here, but this one doesn't allow. Similarly, I would take for customer, drag and drop customer. Now what is that I would like to do now? I've got the dimensions here, but please see I don't have the fact table. There's no fact table here. So now we would like to get the transaction data. For actual as well as plan. Click projection. So let us take two projections. Projection 1 and projection 2. Right click on the projection 1, rename and give the name as actual. Right click on the projection 2, rename and give this as plan. In the projection 1, if you remember, in the last week we have done an exercise like creating a calculation view of type cube. In there we have used two fact tables. One is from C1, the other one from CE2. So if you click on add objects, the table CE1, IDEA is for actual and CE2 IDEA is for plan. Now we would like to do union of both of them. So click union, click on union. So union is to combine results from two or more data sources like tables. Actual join with union and plan also join with union. So here you would see actual and plan. So let us do selection of columns. So select actual projection, click find column, BUKRS. So these are the foreign keys, KNDNR, BB010, BB010 and VV070. So I've taken two foreign keys here. BUKRS for company code and for customer I've taken KNDNR. Similarly for plan. So let us take, click find column. KNDNR BUKRS VV01 0001 and VV07 0001. Now here we have same columns from both this actual as well as plan. And this for actual and this for plan. So we're doing union here. So in the actual we have selected 4 columns and from plan we selected the other 4 columns. And finally in the union we are combining the results from both actual as well as plan. Right click on actual, add to target. Let us map KNDNR to KNDNR and BUKRS to BUKRS and map VV01 0001 to VV07 000, VV07 0001 to VV070. And finally union to start join. Select the start join. Click auto layout. Now we are in the start join. So in the start join, join BUKRS to BUKRS, KUNNR to KNDNR. VV010 and VV070. So here these are the dimensions and these are the columns for the output after union. Click semantics, click validate, save and activate. Completed with warnings, so it's just a warning. Let us see the data. Right click on the calculation view, data preview. So let us see based on company code, what is my gross revenue. So this is my gross revenue based on the company code. But I would also like to see what is the actual and what is the plan. Double click on the star join. Select the star join node. Here we're not able to differentiate what is actual and what is plan over here. So at the union, create target, provide the indicator, and the indicator will differentiate the actual value with the plan value. Length is 10. Click OK. Right click on the indicator, manage mapping. So this will differentiate each row in the output whether this is actual data or the plan data. So give the constant value which is actual and you here as plan. And click OK. Once you have done with this, click save and validate and save and activate. Now once this is done, now let us see now. Right click on the calculation view, data preview. So now we should be able to identify each row uniquely by using an indicator. BU text, gross revenue. So I'm showing the same output as previously, but in this value what is actual and what is plan. In order to know this, we have added indicator over here. In the union. So in order to get to the output, right click on the indicator, propagate to semantics. I just missed this step. I'm just adding this step again. I missed it in the previous case. So propagate to semantics and click OK. Validate, save and activate. Now in the output, we should be able to see the indicator. Right click on the star join, data preview. So here we would see the indicator. So BU text and VV010, we see the gross revenue. Now once you drag and drop the indicator, here it will tell you what is the actual and what is the plan. For example, let us try to filter on US here, on the company code US. So if you drag and drop BU text in the filters, just select best run US. So here is the actual and plan. And here you want to see the percentage variance. 98.98 is actual and 1.02% is plan. But the entire modeling We also done the same procedure in the calculation view of type cube. But what is the difference over here? Now by default, the calculation view of type start join executes on the CE engine explicitly. We can make them execute on the fourth type of engine, which is called SQL engine. If you right click on the calculation view, if you double click on the calculation view, if you click on the free space, just try to click on the free space over here. Anywhere on the work area, you can just click on the free space. Here you would see the properties. At the properties, if you little come down, here you see execute in SQL engine. So once you select SQL engine, executing in SQL engine are faster than CE engine, because SQL engine has the better join determination technique than CE engine. Implicitly it executes on CE, but we can explicitly execute on SQL engine. And start joins have better performance in the SQL engine. So let us compare the performance now between CE and SQL engine. So in the execute in, if you select blank, click validate, save and activate. Now we are actually executing in the calculation engine, but let us do comparison between both of them. Right click on the calculation view, data preview, and drag and drop VV010 and BUKRS, BU text. Now let us see how much time it takes. It takes around 296 milliseconds. Now the same view, I just change the engine. I make it execute in the SQL engine. Click validate, save and activate. Right click on the start join, data preview. So previously it was taking 200 plus, but now let us see, execute the same report, BU text and VV010. So please see, it is taking 200 plus, but here it only takes 125 milliseconds. The model is same, data is same, the logic is same, but the execution is taking place in different engines. And SQL engine is faster than processing on the CE engine. So whenever you use SQL engine, the limitation is we cannot use attribute views or analytic views inside the calculation views of type start join. Now why we are creating a calculation view of type start join is because we have a limitation in the analytic view. We cannot request measures from two fact tables, because if you see the definition of the analytic view, it is based on a single fact table, but a calculation view can be based on several fact tables. So due to that limitation, we have created a calculation view of type star join. In the data warehousing concept, this can be also referred to as snowflake schema when you have more than one fact table. If you have one fact table, then it is referred as star schema. This is like a snowflake schema. Until here, if you have any questions, please go ahead.
Hi, Mr. Rajan. This is Mohammed here. I mean,
Hi,
what's the
Mohammed.
particular reason that this SQL engine is like more faster? What's the particular reason?
The reason is because SQL engine has a better join determination, because we need to still view the visualized plan, and only we'll have then the clear idea why the SQL engine is faster, because I haven't still shown that. But because you asked the question, I'll tell you. C engines, when you use simple operators like different joins, and each join does parallel processing, it does inter-operator parallelism. But what SQL engine does is, it basically processes the entire statement in one single statement, but it takes multiple threads. It consumes multiple threads to process a very big large statement at once. So once it processes a very large statement at once, first it has a better join determination because the entire statement it is processing, and secondly, the CPU consumption is very high. Now sometimes I'll tell you a simple example. Now whenever you go in a car, if you use an optimal speed, let's say 60 kilometers per hour, probably the mileage it gives you is 22 kilometers. But if you go at a 120 kilometers per hour, because the resource consumption is more, the mileage will come down. The same way, the CPU utilization is very high in the calculation view, in the SQL engine. When you see with C engine, which uses optimal consumption of threads inside the CPU. The first reason is it consumes lot of CPU, and the second thing is it has better join determination, because here it has to process each node individually, assemble the result and give back to the user. But here all the nodes are combined to one large statement, and the resource consumption is very higher when you compare with the C engine. Alright, Mohammed? If you have any other questions, please let me know before we see the visualized plan. So we go on to the visualize plan. Ashraf, Ashwat, Murali.
Mr. Nagar, I think this is more than enough for today, I think.
Okay, so what I will do is, please practice until the start join. So tomorrow let us see, as you asked this question, why these engines are faster by seeing the visualized plan. Yeah.
Sounds good.
Yes, please, Mahinder. I'm sorry, I missed your question. May I know who is this? Ashwat?
No, yeah, I said, yeah, that'd be fine, Nagarjuna.
Okay. So we'll meet same time, and sorry for today's delay because I was experiencing some issues in the network. So I had to take the backup internet and use today's class.
Mr. Nagar, this is Zubair here.
Yes, please.
I need to talk to you after the class. Do you want me to stay in the go-to meeting, or do I have to call you after the class?
You can call me on my mobile, Zubair, if you don't mind.
Okay. All right. Can I have your mobile number once again, Mr. Nagar?
Okay, I'll send you in the private chat.
Okay. So can I call you right after the class?
Okay.
Nagarjuna, Mahendra here.
Yes, Mahendra, please go ahead.
Yeah, please share that video to us because we couldn't record it.
Yeah, I'll share you, Mahendra, because I have to upload this and I'll share you. Yeah.
Okay.
Sure,
Thank
sure.
Hello, Nagarjuna, please send it to me as well.
Sure. But could you please drop an email? Whoever wants the video, please kindly drop an email so that I can just reply back the email. Don't mind.
Okay, thank you.
Yeah.